A huge welcome to all maths lovers from Mathlete Minds. We invite you to embark on this voyage of arithmetic progression along with us. But before we do that, may I sincerely request each one of you to kindly like, subscribe, and share the channel as much as possible. In this video, we'll continue our journey of arithmetic progressions and we'll be solving different types of questions pertaining to the general term formula of an arithmetic progression. To begin with, the first question here is determine k so that k square plus 4k plus 8, 2k square plus 3k plus 6, 3k square plus 4k plus 4 are three consecutive terms of an AP. Now, basically, when we talk about the consecutive terms of an AP, we know that if we take out the difference between any two terms of the arithmetic progression, and throughout the sequence they would all be equal, and this is called the common difference represented by small d. Now here these are three consecutive terms of an AP. We do not know the terms numbers, so let us represent them as A, B and C. Now by the very definition of this AP, as I just said, we can write over here B minus A, that is the difference between the first and the second term, or the difference between this preceding term from its succeeding term, will be equal to the difference between C minus B, that is this succeeding term from its, this preceding term from its succeeding term. So this can be rewritten as 2b is equal to a plus c. So this becomes equal to 2 into b, that is 2 into 2k squared plus 3k plus 6, and a plus c can be written as k squared plus 4k plus 8 plus 3k squared plus 4k plus 4. Simplifying the left hand side and the right hand side once again, we get here 4k squared plus 6k plus 12 is equal to 4k squared plus 8k plus 12. So on the left hand side we have positive 4k square. This 4k square gets cancelled with this plus 12 and plus 12 get cancelled. And now we are left only with minus 2k is equal to 0, which implies that k must be 0 in order that these three terms A, B and C are in arithmetic progression. The next question is find the 12th term from the end of the arithmetic progression minus 2 comma minus 4 minus 6 up till negative 100. So this of course is a sequence which is a decreasing sequence, but whenever we get to find the term from the end, we can easily do the solution by reversing the particular AP. So here I'll rewrite this AP in this format, considering minus 100 as the first term and minus 2 as the last term. So here we get this as the first term A. So A becomes equal to negative 100 and the last term L is of course minus 2. Now another important thing that we must remember is here in this original sequence the value of D. The value of D in the original sequence is minus 4 minus minus 2, that is equal to minus 2. So in the new sequence the value of D will become plus 2. So if you check it out on your own, you will get D is equal to plus 2. So now over here, the 12th term, using the general term formula, an is equal to a plus n minus 1 into d, where a is the first term, d is the common difference, n is the number of the term. So here this becomes a12 is equal to negative 100 plus 12 minus 1, that is 11 into 2. So this becomes minus 100 plus 22, that is equal to minus 78. So minus 78 is the 12th term from the end of this particular AP. So this is to be solved this way. Next question is, if the mth term of an AP is 1 by n and the nth term is 1 by m, then show that its mnth term is 1. So mth term of an AP is 1 by n. That means am is equal to 1 by n. And the nth term, that is an, is equal to 1 by m. So using the general term formula, we get here, we can write this as a plus m minus 1 into d is equal to 1 by n, and we can write this as a plus n minus 1 into d as 1 by m. Now this is equation number 1 and this is equation number 2. Now whenever we get the question like this, we are asked to find a particular term. Here it is asked to find the a and nth term and show that this is equal to 1. So in these cases, we must understand that we need to know the value of A and D first. So in order to get the value of A and D, we'll solve these two equations with any of the methods that we have learned earlier. And this is equation number 2. So if I subtract equation 2 from equation 1, this A and A will get cancelled, and the D term, if I take out D common, I'll be left with n minus 1 minus n plus 1 by opening up this bracket. And on the right hand side, we'll get 1 by n minus 1 by m. So D into m minus n is equal to m minus n by mn. So D becomes equal to 1 by mn. Now, in order to find AMN, we also need to know the value of the first term, that is A. So again, we know that D is equal to 1 by Mn. AM term, that is equal to 1 by N. So A means A plus N minus 1 into D. This is equal to 1 by N. Here we'll put the value of D. So we get over here A plus M minus 1 into 1 by Mn, that is equal to 1 by N. So if we simplify this further, we'll get over here A plus, this becomes M by Mn, that is equal to 1 by N, minus 1 by Mn is equal to 1 by N. So 1 by N and 1 by N get cancelled, and if we shift minus Mn to the right hand side, we get A is equal to 1 by Mn. So both the values A and D, they are equal to 1 by Mn. Now AMN can be written as A plus Mn minus 1 into D using the general term formula. So we'll put the values of A and D over here. So AMN will become equal to 1 by Mn plus Mn minus 1 into 1 by Mn. So this becomes equal to 1 by Mn plus Mn by Mn, that is 1, minus 1 by Mn. So this becomes equal to 1. So AMN is equal to 1. So that is what we had to prove. So only thing we need to keep in mind that we need to find out the values of A and D in these type of questions. Ninth term of an AP 6 times its second term. If the fifth term is 22, then find the AP. Ninth term can be written as A9, second term can be written as A2, and the fifth term can be written as A5. So the question says the ninth term A9 is equal to 6 times the second term, and the fifth term is equal to 22. So elaborating on this over here, we can write this as A plus 8D using the general term formula, and this becomes 6 into A plus D. So this on further simplification will give us A plus 8D is equal to 6A plus 6D. So this becomes minus 5A is equal to minus 2D. That means 5A is equal to 2D. So A5 is equal to A plus 4D. This is equal to 22. So here 4D is there. Now we can solve it by any methods. This you can take as equation 1 and this as equation 2, and you can do elimination or anything. But here the simplest approach will be 2D is equal to 5A. So 4D will be equal to 10A. So I'm just putting the value here as 10A is equal to 22. So 11A becomes equal to 22. So A becomes equal to 11. Sorry, A becomes equal to 2. So the sequence will begin with 2, then we need to find out D also. So 5A is equal to 2D, so D automatically, if you put the value of A as 2 over here, 10, so D becomes equal to 5. So if we add 5 to 2, we get here 7. If we add 5 to this, we get here 12, and so on. So the sequence is 2, 7, 12, and so on. So this is the solution of this particular question. Now in the next question that we have, if m times the nth term of an AP is equal to n times the nth term, then show that its m plus nth term is equal to 0. M plus nth term is 0. M plus nth term is 0. So m times the mth term is am and nth term is an. According to the question, m times the mth term is equal to n times the nth term. That means if you multiply the mth term by m and multiply the nth term by n, they are both going to become equal. So m into a, again we apply the general term formula, so we get over here a plus n minus 1 into d is equal to n into a plus n minus 1 into d. Now in this particular questions, see how the solution, now these are both equal. So ma plus md into m minus 1 is equal to na plus nd into n minus 1. Now we'll bring all the terms to the left hand side and the right hand side will become 0. So on the left hand side, if I transfer ma and bring na to the left hand side, I can take out a common from there and write n minus n. And again, if I bring all these this term away, nd into n minus 1, I can take out d common from both these terms and write it as m into n minus 1 minus n into n minus 1. This is equal to 0. So this becomes a into n minus 1, m minus n plus d into, now open up the bracket, you get here m square minus m minus n square plus n. This is equal to 0. Now this becomes a into m minus n plus d, and if we group this terms, m square minus n square minus m minus n, put them inside a bracket so that it becomes m minus n. Now m square minus n square can be expanded using the a square minus b square formula. I hope all of you know a square minus b square formula. So over here in this step, over here we get m minus n plus d into m minus n into m plus n minus m minus n. This is equal to 0. So from these two terms, we can easily take out m minus n common, and we will be left with a plus d into m plus n minus 1 is equal to 0. Now looking at these two factors over here of this expression, m minus, either of them must be equal to 0 in order that this expression becomes 0. So either we can get this expression, this factor as 0 or this factor as 0. But m minus n cannot be equal to 0 because m is not equal to n. So only other option is this a plus d into m plus n minus 1 is equal to 0. That means the m plus nth term, this is a expansion in the general term formula for m plus nth term, that is equal to 0. Next is selection of terms in an AP. Now sometimes we get certain type of questions where we need to select a particular type of terms so that it makes our work very easy. Of course, all these sums that we will be discussing, all these questions that we'll be discussing can be done with a simple way of writing the first term as a, second term as a plus d and so on. But when we take these particular type of selection, for example, if you are asked three term in an AP, then if we take the order as a minus d, a and a plus d, then the common difference over here is d. And if we take four terms over here, we'll get a minus 3d, a minus d, a plus d, a plus 3d, and the common difference over here becomes 2d. In this one again it will be d, and in this one it will be 2d. So whenever we get a set of odd number of terms, the common difference is d. When we get a set of even number of terms, the common difference is 2d. And here again it is odd, so common difference is d, and here it is even, so common difference is 2d. So if we take these selections, the work becomes extremely easy, and that we can see in the subsequent questions that we are going to solve right now. So let us take the next question over here that is based on these selection of terms. Sum of three numbers in an AP is -3 and the product is 8. Find the numbers. Now here we are given sum of three numbers in an AP. So what happens if I take my selection as a minus d, a and a plus d? If I add them up, if I add these three terms, alright, these three terms, then what am I going to get? A minus d plus a plus d, it is equal to -3. So then minus d and plus d will get cancelled. We are left with 3a is equal to -3. So this means that a is equal to negative 1. So we easily get the value of a if we proceed with a particular selection of terms. So if you remember this, try to apply the selection of terms so that your work becomes easy. Now the second part of the question says, and the product is a. That means a minus d into a plus d. That is equal to 8. So a square minus d square into a, that is equal to 8. Putting the value of a over here, this will become 1 minus d square into negative 1 is equal to 8. So which gives us 1 minus d square is equal to negative 8. Or or d square can be written as equal to 9, or d can be written as plus minus 3. Now, when we are choosing the terms, we cannot opt out with plus or minus 3. We have to take both of them into consideration over here. So, if we now take the terms a minus d, a and a plus d, first term is a negative 1. So, if I take the first term, if I take the common difference as plus d over here, in that case, the first term a minus d will become equal to 1 negative 1 minus plus 3. That gives us minus 1 minus 3, that is minus 4. So the first term becomes equal to minus 4. Second term is already minus 1, and the third term a plus d, that is equal to minus 1 plus 3, that will be equal to 2. So these are the three terms. And if we take negative 3, in that case the order of the terms will reverse. So the first term will become 2, next is negative 1, and then this next is negative 4. So these will be the terms of this particular AP. Find four numbers in an AP whose sum is 20 and sum of the squares is 120. So we have to find here four numbers whose sum is 20 and the sum of the squares is 120. So the four numbers, supposing we take them, represent that with a minus 3d, a minus d, a plus d, and a plus 3d. So these are the four numbers in the AP. And now again, if we take the sum as 20, as in the previous case, we'll get your 4a is equal to 20. So a is equal to 5. So immediately you get the value of a. Now the question says sum of the squares is 120. That means a minus 3d the whole square plus a minus d the whole square plus a plus d the whole square plus a plus 3d the whole square is equal to 120. So expanding this, elaborating this using the formula of a minus b the whole square and a plus b the whole square, we get over here a squared minus 6ad plus 9d squared plus a squared minus 2ad plus d squared plus a squared plus 2ad plus d squared plus a squared plus 6ad plus 9d squared. So ultimately, after simplification, these terms will get cancelled, the middle terms will get cancelled, and we will be left with 4a squared plus 20d squared is equal to 120. So this gives us a squared plus 5d squared is equal to 4 3's 12, and this is 30. Now a is already 5. So if we put the value of a as a squared will become 25. So 25 plus 5d squared. 25 plus 5d squared is equal to 30. So we get over here 25 plus 5d squared is equal to 30. 25 plus 5d squared is equal to 30. So 5d squared will become equal to 30 minus 25, that is 5. So d squared will become equal to 1. So d is equal to plus minus 1. Now in order to choose the select the terms, the first term was a minus 3d. The second term was a minus d. The third term was a plus d. And the fourth term was a plus 3d. So here to get the terms, now we got a, the value of a as equal to plus 5. So the first term, of course, will, if we take the positive value of d first, we'll get over here 5 minus 3d, that is 5 minus 3 into 1. So we get over here 5 minus 3, that is 2. This will become 5 minus 1, that is equal to 4. Then this will become 5 plus 1, that is 6. Next will become 5 plus 3, that is equal to 8. So these are the terms if we take d value as plus 1. If we take the value of d as negative 1, the order will change and we will get the sequence as 8, 6, 4 and 2. The next question is again pertaining to 4 consecutive terms in an AB. The sum of 4 consecutive terms in an AB is 32 and the ratio of the product of the first and the last terms to the product of the two middle terms is 7 is to 15. So here's a lot to be understood. 4 consecutive terms. We do not know the number of the terms. So whenever we get 4 terms, we can take the sequence as A minus 3D, A minus D, A plus D and A plus 3D. So if we take the summation of this, automatically we'll get here 4a is equal to 32. That means a is equal to 8. So we get the value of a is 8. Now the question says the ratio of the product of the first and the last term. This is the first term, this is the last term, and these are the middle two terms. So if we take the ratio of the product of the first and the last term, that means a minus 3d into a plus 3d, which will automatically give me a squared minus 9d squared. And the middle two terms will give me a product a squared minus d squared using the formula a squared minus b squared. So we get this relation a squared minus 9d squared is equal to by a squared minus d squared is equal to 7 by 15. On cross multiplication we get here 15a squared minus 135d squared is equal to 7a squared minus 7d squared. So this becomes 15a squared minus 7a squared. So that is going to give us 8a squared is equal to 128d squared. So a square is equal to 8 ones 8, 6, 8, 48. A square is equal to 16d square. So this is the relation between a and d. Now a is already 8. So a is 8, so we put the value of a square as 64 is 16d square. So d square becomes equal to 16 4 64. So d is equal to plus minus 2. So in this case the sequence will become d is equal to plus minus 2. The terms are a minus 3d, a minus d, a plus d and a plus 3d. These are the terms. If a we have found out as in this particular question a was equal to 8. So here if we take a as 8 and we write down the terms in the sequence, if we take plus 2, then this first term over here will become 8 minus 6, that is equal to 2. Second term will become 8 minus 2, that will be equal to 8 minus 2, that will be equal to 4. Sorry, 6. The third term will become 8 plus 2, that is equal to 10. And 8 plus 6 again, that is equal to 14. So here you see the common difference is 4 in all of in all these cases, in each of these terms. Alright, the terms are 2, 6, 10, 14. So these were the terms that were taken which gave us the common difference 2D in every case. So the 4 terms are this way, and here if we rewrite the term by taking negative 2, then the first term will be 14, the second term will be 10, the third term will be 6 and the last term will be 2. So these are the terms of the AB. So this way, of course, here we got d is plus 2, but when we put down the terms in that particular sequence, the terms are coming 2, 6, 10 and 14. So we should not get confused here. Between the difference between each of the terms, like 6 minus 2 is 4, 10 minus 6 is 4. This is 2D because we have taken the terms in such a way, whenever it is an even number of terms, the sequence is taken in such a way that the difference is 2D. So these 4 terms will be giving us the particular sequence of the AB. So with that we come to the end of this video. Hope you like the explanation. Kindly like, subscribe and share the channel as much as possible. Thank you for watching.